All right, let's talk about caching. It's this powerful and frankly perilous tool that can either make your software fly or bring it crashing down. You see, caching promises incredible speed and scale, but as we're about to find out, it hides some pretty serious dangers. And you know, this classic quote from computer scientist Phil Carlton, it just hits the nail on the head. It perfectly captures this hidden complexity we're about to unpack. Caching seems simple on the surface, but getting it right, that's one of the toughest challenges in engineering for sure. Okay, so let's start with the good stuff, the promise of caching. It's often called the Swiss Army knife of system design, and for good reason. When it works, man, it solves a whole bunch of problems all at once. And here it is, the core paradox laid bare. On one side, the benefits are just incredible. Your system feels way snappier. It stays online more reliably, and it costs less to run because you're not hammering your expensive backend database for every single little thing. But, and this is a big but, on the other side, you're introducing this whole new layer of complexity with its own unique and pretty dangerous ways to fail. So how do we know if a cache is actually doing its job? Well, it all comes down to one crucial number, the cache hit ratio. It's really simple. It's just the percentage of times a request finds what it's looking for in the cache. A high hit ratio? Everything's running smooth. A low one? Well, that's when the trouble really begins. Just look at this difference. It's staggering. A system with a healthy cache can cruise along handling, say, 10,000 transactions per second. But its backend, it can only handle a tenth of that. So as long as that hit ratio stays high, you are golden. But the second it drops, your backend gets absolutely flooded with 10 times the traffic it was ever built for. And yeah, the whole thing can just come tumbling down. So, what happens when that cache hit ratio does falter? That's when the villains of our story emerge. And these aren't just some theoretical problems, okay? These failure modes have caused real-world, multi-hour outages for some of the biggest services you use every day. First up, we've got the doom loop. And trust me, it is every bit as bad as it sounds. It's this vicious cycle that's incredibly difficult to stop once it gets going. It starts with just a single point of failure, and then it just spirals fast into a total system collapse. This here is basically a domino effect. Just imagine, all your cache nodes are running near capacity. Then one node fails, maybe during a routine update, nothing special. Bam, its traffic instantly spills over to the other nodes. But they can't handle the extra load, so they start to fail too, pushing even more load onto the few that are left, until the entire cluster is just offline. Next up is the thundering herd. And if you've ever seen a website for concert tickets crash the exact moment they go on sale, you have probably witnessed this firsthand. You have a single, super popular piece of data, like a viral news article that expires from the cache. And suddenly, thousands, maybe millions of requests all slam the backend database at the exact same millisecond. The database just can't keep up. And we can't forget these two. They're kind of the silent killers. Inconsistent data is when different parts of your cache have different versions of the truth, which leads to all sorts of bizarre and unreliable behavior for your users. And then there's the forever cache. This is what happens when someone just forgets to set a policy to remove old data. The cache just grows and grows and grows until it eats all its memory and crashes, which, by the way, often kicks off that doom loop we just talked about. Okay, so we've met the villains. It sounds pretty grim, right? But it's not hopeless. There are well-established strategies to make your caching layer much, much more resilient. Let's open up the playbook. The main idea here is to build in layers of defense. For instance, an L2 cache can act as a backup buffer to protect your database if the main cache goes down. Request coalescing is a clever trick that bundles thousands of identical requests into just a single query to the back end. Then you have sensible caching tactics like preloading popular data before it's needed, or even negative caching, which is storing the fact that some data doesn't exist so you stop wasting time looking for it. And finally, you absolutely need proper eviction policies to decide what data to get rid of when the cache fills up. And yeah, choosing the right eviction policy is absolutely critical when your cache hits its limit. The last thing you want is to accidentally kick out a popular item and cause a thundering herd. The right choice really depends on how your users access data. LRU is great when recently used stuff is likely to be needed again, while LFU is better when some items are just popular all the time. And check this out, here is a brilliantly simple tactic. Instead of having every single copy of a popular item expire at the exact same microsecond, you add a tiny, random amount of time to its expiration or its time to live. This jitter staggers when things expire, preventing that massive simultaneous rush to the back end. It's such a tiny change, but it can literally prevent a self-inflicted disaster. But honestly, the biggest takeaway here isn't just one technique or trick. It's a fundamental change in philosophy. All the tools in the playbook are important, but they only really work if you start with the right mindset. So the most crucial point is this. Stop thinking about if your cache will fail. It will. I promise you it will. Instead, you have to design and build your system for when it fails. You have to assume that failure is just a normal part of operations. So how do you do that? You test for it, proactively. One really powerful way is to intentionally inject a small failure rate, maybe 10%, into your cache queries, in a test environment. You force your system to practice its fallback plan for when the cache isn't there. And this is the question you have to ask yourself. If a tenth of your cache just disappeared right now, would your backend survive? Or would it trigger that doom loop we talked about? Just asking this question shifts your focus from trying to prevent every single failure to instead gracefully surviving them. It helps you find the weaknesses before your users do. And that right there brings us to our final thought. This isn't really just about caching. It's about a much deeper principle for building truly resilient systems. It's about challenging our own assumptions, embracing failure as an inevitability, and designing systems that aren't just fast, but are fundamentally, unshakably robust.